All right, welcome to section 13.5, page 2. And I have to confess, I lied to you. The binomial table is actually not in your book. So you really do need to find the binomial table that I printed out for you. Okay, so if you haven't found it, pause, go find it, start the video up again. Okay, so let's talk about this notation, what it means, and what the answer to these problems are. So this first one here says, explain the meaning of the expression and compute its value using the binomial table. So what we're being asked to find, let's write along the side here. We are being asked. Okay. In a binomial experiment, so this the B tells you we're in a binomial experiment. In a binomial experiment, this is asking you to find the probability of, okay, so if you recall, this is the N, this is the K, and this is the P, okay? So that K is the number of successes. Let's write this up here. N equals the number of trials, which means number of times the experiment is performed. Okay, K, what is it equal to? The number of successes. And little p here is the probability of success. Okay. So we're being asked, in a binomial experiment, find the probability of K successes, so that means of 2 successes in how many trials? 8. 8 trials when the probability of success is 0.1. Okay, so that's what we're being asked to find. All right, so how do we find it? We're going to go to our table. Okay, so the most important thing to look for is what N is. How many times are you performing this experiment? Well, it tells us 8. So we go along here. Here's N. So we're going down here until we find 8. So this column goes to 7. So then we need to move over here. Here's N again. Here's 8. So we've located 8. Okay, that's the number of trials. Then we're going to go over to K. I can see a problem here. This chart says X. So why don't we go ahead and change this to X so that it matches the chart. Okay. Okay, so now it matches our chart. So X needs to be 2. Okay, so here's 8. That's for our N. Then our X is 2. Okay, so now we're talking about this whole line here. This is what we're interested in. That's the only thing that matters. Okay, so to make it easier, let's do this. All right, that's all that matters. Then, what probability are we looking for? 0.1. So that's 0.1. So what we want is just right here. We're in N equals 8. We want an X of 2, and we want a probability of 0.1. So here's the number, 0.149. So let's go ahead and write that down. B of 8, 2, 0.1 equals 0.149. Okay, so now we can answer the question. Okay, so the probability of getting 2 successes out of 8 trials when the probability of success is 0.1 is 0.149. Okay, now let's make sure that this makes sense to you. So you're doing something like, since the probability of success is 0.1, why don't we say that we are rolling a 10-sided die, and what we're looking for is we want the number to turn up as a 1, okay? So we have all the numbers 1 through 10, so the probability of getting a 1 would be 1 out of 10. So the probability of rolling a 1 is 0.1. Hopefully that makes sense, okay? So then we want to know, if we roll this die 8 times, this 10-sided die 8 times, what is the probability that we are going to get twice, that it's going to come up 2 times, it will come up as a 1? Well, the answer is 14. Let's go ahead and write 14.9%. Okay? So we have basically a 15% chance that if we're rolling a 10-sided die, that we would end up with rolling a 1 twice. Okay? That's what we're saying here. All right, let's try this next one now. So here, what are we being told? We're being asked to find, it's a binomial experiment. How many trials do we have? I shouldn't have drawn the arrow. I should ask you. 5 trials, okay, so that's n. How many successes do we have? 1 success, okay? And this is the probability of success, okay? So let's use the chart, and then let's use the chart to get the answer, and then we'll interpret what it means. Okay, so let's see. Let's look at our chart. We are trying to find, n is the number of trials. So we go along here, n. We're running along here. 1, 2, 3, 4, 5. There's n equals 5. So we know we're in this area right here where n equals 5. Not above it, because that's where n equals 4. Not below it, that's where n equals 6. And then we need our x, so we go down this column, x is 1. All right, that's what's important to us. So let's go ahead and go like that. So once again, n equals 5, x equals 1. Now, to know which of these numbers we need, we have to look and see what the probability is. Well, the probability is 0.3. So let's look again. Up here in this column, 0.1, 0.2, 0.25, 0.3. So we're in this column. Let's go down. And we're in this row. So it's just like using a multiplication chart. That's our answer. 0.360, okay, is our answer. So let's go up here and write this. Okay, it's equal to 0.360. Okay, so what is it that we just found? The probability of getting how many successes? Well, what's this one? That's the number of trials. What's this one? That's the number of successes. So of getting 1 success out of 5 trials when the probability of success is 0.3 is, here's our answer, 0.360, or, oops, if we wanted to turn it into a percent, or 36%. Okay? So if we wanted an example of this, let's just say that that's approximately a third. So suppose you have a multiple choice test that the answers are like A, B, and C. So every time you guess, your chances are about 30% or really 33%, 1/3, okay? So that would be saying if you have 5 questions, okay, you want to know what's the probability that you got 1 right. So you've got 3 possible answers. That's what's giving you the approximately 0.3 probability. So we would say, well, the chance of you getting 1 question right would be out of 5 when your probability of getting it right is 0.3 is equal to 36%. Okay? So when you're thinking of these probabilities, kind of don't worry so much about this. Okay? Think about 5 trials, 1 success. Okay, what's the probability of 1 success in 5 trials? Well, it's 36%. Of course, the probability does matter, but for the understanding, think of it that way. Okay, one more example. So here, when I look at this, I realize that there were no fractions on that sheet, on our binomial table sheet. So I've got to figure out this fraction is what in decimal form. So let's go ahead and figure out what that is. If you don't know it already, you're going to take 1 divided by 5, and that's equal to 0.2. Okay, so this is really equal to, this is the same as b of 3, 0, 0.2. Okay, so now let's use our table. All right, so where are we going with the table this time? Well, the first number we have, remember that's the n. So this is your n, this is your x, this is your p. Okay, so n is 3. So we go down here until we get n equals 3. Here it is. Okay, move that up a little so you can see it. Okay, and then 0 successes. So here we are at 3, here we are at 0 successes, and the probability is 0.2. So let me take my little sheet here. So here we are. This is the line we're interested in. N is 3, x is 0, and then our probability is 0.2. So we're right here at the second number. So 0.512. Okay, so that's equal to 0.512. Okay, so let's answer this one in words. It's saying that, let's write this. Okay, the probability of getting how many successes? Which one of these is success? Not this one, that's trials. This one is successes. So 0 successes out of how many trials? 3. With probability of success. I didn't spell that right, did I? With probability of success being 1/5 is 0.512, or move it over 2 decimal places, 51.2%. Okay, so now let's think about what that all means. Okay, so if you're performing a trial 3 different times, so let's say rolling a 5-sided die, okay? And suppose I want the number 5 to appear. So what's my probability if it's a 5-sided die of getting 5 to appear? Well, 1 out of 5, so 1/5. So we're rolling this 5-sided die, okay? We do it 3 times. What's the probability that we never get a 5? 0 successes, we never get a 5. Well, they're saying that's pretty likely. We have a 51.2% chance of never getting a 5 when we roll 3 times, okay? All right, so that's it for this page. I would like you to do this classwork problem and then go on to page 3 of the video.